one of the publishers that do the AP prep books, these questions come from those. So, and these questions were very similar to what you could expect to see on the exam. Although, again, they are not exactly the same. They're not exactly AP questions. But the level of the questions and the depth of the questions are about what you are.
Over there. Yes.
Okay, what's the force? Well, the force has to, the force of the weight has to be equal to the frictional force. Because the frictional force is what is stopping the motion, then the weight must be equal to the frictional force. So the frictional force has to be equal to the force. The system is released. What is the acceleration? Well, you're told that it goes down 0.5 meters in 2.2 seconds, so solve for your acceleration, 0.21 meters per second squared. Okay, what is the coefficient of friction? Okay, then your net force is equal to your total mass times your acceleration. Your net force is the force of the weight minus the frictional force is going to cause both masses to accelerate. Okay? Solve for your frictional force. You know what the weight force is. You know what your acceleration is. You know what your sum of your masses is. Solve for the frictional force. Then once you know what the frictional force is, solve for the coefficient. The coefficient of 0.22. So solve for your frictional force, and then solve for your coefficient. How far will the block have moved in 1 second? It's accelerated motion. Okay? And the AP people hit that particular aspect hard. They want to make sure that you know the difference between accelerated motion and constant velocity. And what is the speed of both blocks? Solve for final velocity.
It's like it's a test.
0.04 meters per second squared.
Except I failed this one.
Just look at the next page.
So again, not an AP in that it is not a college, right from the College Board, but very similar to what the College Board would say. The questions on the AP exam are not difficult. Okay? They are comprehensive, which means that you have to know everything when you walk through the door.
There we go. Just know the universe.
Okay, we have the block circling. Okay, what is the mass? Well, I know that my centrifugal force, which is my weight, is equal to mv squared over r. Okay. Well, I know what m is for the small block that's in the circle. I know what v is. I know what r is. I can solve for the centrifugal force, which is the weight of this block. And then once I know what the weight of that block is, I can solve for the mass because W is equal to mg.
Its velocity is 1.
Divided by 9.8.
It only goes 0.452 seconds.
The string breaks, setting the block off the table. Classic AP style question. Here's your motion in 2 dimensions. And it's going to be on that exam on May 10th somewhere. It's there every year. But again, rarely is it a freestanding question. They wrap it into something else. So here's your motion in 2 dimensions, wrapped into a circular motion problem. Time depends on the vertical displacement. Horizontal velocity depends on horizontal velocity, or tangential velocity in this case.
3D.
With what total velocity does the block hit the floor? Okay, your total velocity includes horizontal and vertical. Well, your horizontal velocity you know, because that was given. That was the 1. You need to solve for your vertical velocity, which is the speed that it's moving down. Well, you know how long it was in the air. You know what gravity is. Solve for VF. And then your total velocity is a squared plus b squared gives you c squared. So that's your total velocity, represented 1 meter per second in this direction, and 4.4 meters per second in this direction.
Death packet.
So your total velocity is the hypotenuse of the triangle. Your angle is 77.3 degrees relative to the floor.
Oh, I didn't know we had to find. Oh.
The block hits the floor and doesn't bounce. How far does it slide? Well, you have accelerated motion here, okay? Because it starts out horizontally at 1, it goes to 0 in 0.4 seconds, and when it goes 0.2 meters. Then what's the coefficient of friction? Well, you know what the acceleration was, because you went from 1 meter per second to 0 meters per second in 0.2 seconds. Acceleration is 2.5 meters per second squared. Based on that, you can solve for the force, and based on that, you can solve for your coefficient. Okay, again, not difficult, question for question. But, again, it's the range of questions that makes the AP exam challenging. The fact that you've got one question, which is friction, and the next question is motion in 2 dimensions. And the next question is energy, and so on. How far up the ramp does the car travel? Well, KE, which is your velocity-related energy, is equal to PE. Okay? Solve for your change in height, and then solve for how far that is up the ramp. In other words, you will get this dimension, which is your 0.319, because that's the delta H, always vertical. What they want is this dimension along the incline.
Mine was
So you have
lost
to go
easier.
back, use your trig function.
It used to be squared up plus b squared up plus 2ad.
What's the car's gravitational potential energy? Halfway up. Okay. Well, half your distance is going to be half your length, which is half your height, which is half your energy.
What? No, I can't. Okay, it's just all the calculus. Yes, so I think. Well, actually, no, I didn't do energy.
What is the kinetic energy of the car? Because it's not, it does work
I
out.
did acceleration.
You know what your potential energy is? You know as you go up the ramp, your energy is split
Easier.
between potential energy and kinetic energy. So if you've got that much potential,
This page is 1.
whatever's left over has to be kinetic.
30 for 30.
And the cart is now removed from the ramp and hung from a spring. Okay, all of a sudden, we've gotten from energy to springs. And the AP will do this too. Again, they've got certain topics that they have to cover, so they'll link all of these questions in and somehow answer them in the end. So how far will it stretch? What's going to make it stretch is its weight. So I got a 3 kilogram cart times 9.8, 29.4. I know what my spring constant is. How far will it stretch?
Not only yet. You fall. One.
Question.
Are we talking about it yet?
What does it say for?
No. He shows it when we start talking about it.
For the stretch? 0.3267?
Clearly, we're not talking about it. Not yet. Exactly.
Okay, the energy, my potential energy I found here. My kinetic energy I found at the very beginning. So the difference is total kinetic energy minus potential energy gives you kinetic energy left over. So in the very first question, you had to find total kinetic energy, which was 9.375. Okay? And then for this one, you found out what was kinetic energy, and then what's left over has to be kinetic potential.
I don't care. No, it does. Like, if we really it's like if we start talking, it picks us up really easily. Because I listened to one, and I start talking at the end.
Okay, determine the force of rolling friction. Well, the frictional force is the coefficient times the normal force, which in this case is just the weight, because you're on a horizontal surface. So your frictional force, 0.225 newtons. What minimum energy must be imparted to get the ball to the cup? Well, you're going to lose the frictional force times the displacement as it travels to the cup. So the initial energy has to be at least equal to the energy that you would lose in friction. So your frictional energy or your force energy is 1.75 joules.